Welcome back, class, and thank you for joining me. So today we are diving into a new type of sequence. So the past two lessons we've talked about arithmetic sequences, sequences you get by adding the same thing to every single term. Today we're introducing a new idea. We're introducing something called a geometric sequence. Geometric sequence is a sequence of numbers where the ratio of a term with its previous term is constant. This is called the common ratio. So this time, to get from term to term, you are multiplying by that common ratio. So that's the only difference, multiplying instead of adding. So let's take a look at what this looks like. So determine if the following are geometric sequences. For any that are, identify that common ratio. All right, so let's see here. So if we're checking to see if it's geometric, we need to see what are we multiplying by. Well, 3 times what gives you 6? Well, you're multiplying by 2. Or you can also always check by taking 6 divided by 3. Take the next term, divide it by the current one, and that'll give you what you'd be multiplying by. 6 times what gives me 12? Or 12 divided by 6 is 2. 24 divided by 12 is 2, and 48 divided by 24 is 2. So this one truly is geometric. We are multiplying by that same number over and over again. And what is that number? Well, that number is 2. All right, let's try this one. So to go there, 6 divided by 3 means I was multiplying by 2. 9 divided by 6. Oh, that means I was multiplying by 1.5. Well, that's not the same thing. So already we can tell that this one is not geometric because we're not multiplying by the same thing consistently between every term. So I'm going to rule that one out. Not geometric. And this next one, now this one's written a little bit funky, but it works. So here, think about it. 3 squared is 9. 3 to the third is 27. 3 to the fourth, 81, so on and so forth. So how am I getting from 3 squared to 3 to the third? Well, 3 to the third divided by 3 squared gives you 3. How do I get from 3 to the third to 3 to the fourth? Well, 3 to the fourth divided by 3 to the third times 3. Same thing here, times 3. So this one is again geometric with an R of 3. All right, now, just like we had before, there's 2 ways we can represent these. We have a recursive definition, a recursive formula, and we have an explicit formula. So, recursively, just to go back and show you what that would look like in these instances, so we have an R of 2 here in this first one. So recursively, I would label that my A1 is 3. And then to get to a future term, what am I doing? Well, I'm taking a to the n minus 1, and I'm multiplying it by that r. I'm multiplying it by that 2. All right, recursively over here, identify my first term as 9 or 3 squared, whichever you prefer. And then recursively, I would identify that every one of my terms, I take my previous term and I'm multiplying it by that r. So again, that is a brief introduction to the recursive side of these formulas. Now again, we discussed on that very first day that usually explicit ends up being better for us because that's how we can find future terms. So similarly to arithmetic sequences defines the nth term of geometric sequence, you have to identify A1 and R. And again, the only thing that's different about that is arithmetic, you find A1 and D. You use those values to make an explicit formula, plug in n to get the nth term. All right. So we want to know, what is the 10th term in the geometric sequence 4, 12, 36? So first we have to identify our R. And again, this one is obvious. We know we're multiplying by 3. But if you ever struggle seeing what you're multiplying by, just take 12 divided by 4. That gives you 3. 36 divided by 12. That would give you 3. So I know that my A1 is 4, that my R is 3. All right, now let's look back for 1 second at that explicit formula. So this time we're going to be using this setup, A1 times R to the n minus 1 power. So AN equals A1, which is 4, times R, which is 3, to the n minus 1. Now, the commonality I want you to see here is that whole n minus 1 idea. Remember, arithmetic did that too. Okay, so it's very important to remember the whole minus 1 piece, n minus 1. So that's all it takes to write the explicit formula. And now from there, I want to find the 10th term. Well, let's plug it in. A to the n equals 4 times 3 to the n minus 1. Well, that's going to give me that. 4 times 3 to the 9th. So, we plug that into our calculators. And again, I'd recommend plugging it in right along with me to make sure you're getting the right answer. When you do that, you get 78,732. That is going to be the 10th term of that sequence. What is the 6th term in the geometric sequence? 10, 5, 2.5. So again, this is one of those examples where I said sometimes it may not be obvious or may be tricky. So we need to identify A1, which is 10, and we need that R. So you're probably thinking, oh, I'm dividing by 2. Now, be careful though, because all geometric sequences are in terms of multiplication. So to get what you're multiplying by, it doesn't really matter that you're dividing by 2. What you have to understand, 5 divided by 10, you're multiplying by 0.5. 2.5 divided by 5 means multiplying by 0.5. So make sure you understand that you need 0.5 or 1/2. Okay? It's very critical that you think of it in terms of multiplication, not division. You're multiplying by 0.5. All right, so that gives us what we need to set up our formula. A to the n is A1 times R to the n minus 1. So it wants us to find the 6th term. So I'm going to plug in 6. So 6 minus 1 gives me 5. So I need 10 times 0.5 to the 5th power. And that is going to give me 0.3125 when I plug it into my calculator. And again, make sure you're able to get that same thing. Now, if you want it as a fraction, so it's a little bit nicer, you can get your calculator to turn into a fraction. That would be 5/16. All right. So let's look here. During your first week of training for a marathon, you run a total of 10 miles. You increase the distance you run each week by 20%. How many miles do you run during your 12th week of training? All right, so this is the same idea. We're being asked for a future term. And how do I know it's geometric? Because it's increasing by a certain percent each year. All right, so we need A1 and we need that R that we're increasing by. So the first week, it says we ran 10. All right, and we increase the distance by 20% each week. So 20% on top of what we've already done. So that means we're going to be multiplying by 1.2. That 20% as a decimal is represented by 0.2, and we're doing that on top of what we've already done. So that's how I'm getting that 1.2 there. Okay? So with that 1.2, now we're able to write our formula. So 10 to the 1.2 n minus 1. And we're being asked about our 12th week. So I want to find A12. So 12 minus 1 up there, well, that's going to mean 11. So let's plug this into the calculator. 10 times 1.2 to the 11th. Now, this one is getting really obnoxious with the amount of decimals. So here, just give an appropriate number of decimals. So here we have 74.3. Then we have a couple zeros after that. So 74.3 is going to be just fine. So 74.3 miles is what we are going to run. All right, so if you could flip the page, we have one more example to do together, and then we will be done. All right, when a ball bounces, the heights of consecutive bounces form a geometric sequence. What are the heights of the fourth and fifth bounces? So here we're given the first three, 100, 70, 49, and we want to know the future terms. All right, so using geometric formulas, we know we need the first term and we need that rate. Our first term is 100. Now, remember what I said. This time it's a little less obvious. So think about the geometric series. Okay? So remember I said to figure out what that rate is going between, you can also divide them. So to figure out what you're multiplying by, take 70, divide it by 100. That's going to be 0.7 that you are multiplying by. All right? So if we want to set up our formula, A1 times that R to the n minus 1. So that means when I want to find the fourth term, I just have to plug this in. And let's see what that is. 100 times 0.7 to the third is 34.3 centimeters. And it asks for the fifth term. So you plug a 5 in. So 100 times 0.7 to the fourth is 24.01 centimeters for that fifth bounce. Okay, so again, same thing. You find that first term, you find that R, the common ratio, and that gives you everything you need for your explicit formula to find future terms. All right, and that is all that I have for you today. So thank you for joining me for this. Make sure you have everything written down, and then come back prepared to do your practice work.